Lesson 7-3, Multiplying Powers with the Same Base. So in these next two lessons of Chapter 7, we're going to learn or review some rules of when we have exponents and we're multiplying. All right, so this first property that we want to make sure we have in our notes is when you're multiplying numbers that have the same base. For example, 3 to the 4th being multiplied by 3 to the 2nd. Notice the base in both of these factors is 3. So in the first one, 3 to the 4th is 4 3's being multiplied to 2 3's. Well, if you add up how many 3's that is being multiplied, 4 plus 2 is 6. So the algebra property is when you have the same base, you can just add the exponents. So let's do that with an example. All right, 12 to the 4th times 12 to the 3. They both have the same base, so our answer is going to have 12 as a base. And then the exponents, we can just add. So 4 plus 3 is 7. 12 to the 7th is how I would write this with the base written only once. It's not completely simplified because we could find out what 12 to the 7th power actually is. In B, I have negative 5 raised to the negative 2 being multiplied by negative 5 raised to the 7. Again, same base, so my base is negative 5, and my exponents can be added. Negative 2 plus 7 is a positive 5. All right. Now they're going to throw in an algebraic expression, so we have some variables. The rules apply to the algebraic expressions just as they do to the numerical ones. So in this example, 4z to the 5th power times 9z to the negative 12th power. Well, because of the commutative and associative properties, I can regroup this because it's all being multiplied together. So I'm going to pull the 4 and the 9 and multiply those. I get 36. And then my z's, z to the 5th times z to the negative 12th. Well, it has the same base. I'm going to add the exponents. 5 plus the negative 12. I'm going to get negative 7. 36z to the negative 7. Now, finally, to simplify this, I can rewrite it using a positive exponent. 36 will stay on top. And z to the negative 7th, I can put on the bottom so that my exponent becomes positive. So there's my final answer, 36 over z to the 7th. All right, and then I'm going to clear this and do example B. 2a times 9b to the 4th times 3a to the 2nd power. I'm going to ignore what they have here and just do it myself. So this can all be rewritten. I'm going to write the numeric factors together first. 2 times 9 times 3 I'm pulling. And then I have 1a, I have a b to the 4th, and I have an a squared. So first, 2 times 9 times 3 is going to give us 54. A to the 1st power times a to the 2nd power, they have the same base, so I'm going to add the exponents. 2 plus 1 is 3. And b to the 4th just gets to hang out and come along. Final answer, 54, a to the 3rd power, b to the 4th. All right, you can use the property for multiplying powers with the same base to multiply two numbers written in scientific notation. All right, so here I have two numbers being multiplied. They're both written in scientific notation. I can do the same thing where I rewrite the order of my factors being multiplied. I'm going to multiply the two numbers first. 3 times 5 is 15. And then 10 to the 5th times 10 to the negative 12th, they have the same base of 10. I'm going to add the exponents. 5 plus negative 12, and I get negative 7. 15 times 10 to the negative 7th is my answer. But that isn't written in scientific notation quite yet, and it wants us write your answer in scientific notation. It says in the directions. So 15 is not between 1 and 10, so I'm going to put the decimal point between the 1 and the 5, 1.5 times 10. Since I moved my decimal point left, I'm going to add an exponent. Negative 7 plus 1 is negative 6. So there's my final answer written in scientific notation. All right, problem 4. This one can be a little confusing just in the example they used and the way they word it. The got it problem is a little bit easier to, the problem in the lesson check. All right, so at 20 degrees Celsius, 1 cubic meter of water, right here, has a mass of about 9.98 times 10 to the 5th grams. Each gram of water contains about 3.34 times 10 to the 22nd molecules of water. About how many molecules of water does the droplet of water shown below contain? All right, so they use this volume formula for this water droplet right here. And we're going to multiply that by the mass, 9.98 times 10 to the 5th, times how many each gram of water contains. That was this scientific notation number right here. So once you have this formula set up, we can pull out all the first factors in each parenthesis group. 1.13 times 9.98, 1.13 times 9.98 times 3.34, and we get 37.7, I'm going to round, times 10, we have negative 7, and I'm going to add the exponents, plus 5, plus 22, 10 to the 20th power. My answer isn't in scientific notation quite yet. We want to make sure we do that. So I'm going to move the decimal point one way this way, 3.73 times 10 to the 21st molecules of water. So that was a real life example. All right, that brings us to the lesson check. Complete 1 through 4. What I was saying is number 4 is a little bit easier to understand the real life problem and how to set it up. But good luck to you, show your work, and bring your answers to class.